This video is for the Angular Calculations 2 assignment in your workbook. This assignment can get just a little bit tricky, but it also relates very much to the Angular Calculations 1 exercise. So I just want to point out a few things that might look a little bit different. I'll start off, and it really doesn't matter what you call this view that looks similar to what's in the text, okay? But what does matter is that you understand the rotation. So to get the view at the top of the workbook page, is rotating the object toward the top of the object toward you by 90 degrees. To get the bottom view is rotating the bottom of the object toward you by 90 degrees, and the right and left side are what you're accustomed to. And you get a layout like this one, and they give you one angle, okay? So let's just say that mine is 51. Okay, so that means, and this translates to yours. Not you'll be using a different angle measurement, but mine's 51. This angle over here is also 51. This angle is 51. This angle is 51. So on and so forth, all the way around. Okay. So some of the dimensions that you'll be asked to find is actually just like the last thing I talked about in the Angular Calculations 1 video, which is a situation where you have two parallel lines and one line intersecting it. And remember, we dimensioned one of those, okay, as 42 degrees. Now, just knowing the geometric principle, I know that these two lines are parallel. I have a line cutting through them. Just because I know the geometric principle, if I know that this angle is 42 degrees, I also know that the angle between here and here is also 42 degrees. So that is actually one of the angles you'll have to find, is like the outside angle. I also know that if I were to draw a line from the intersection point straight down, perpendicular across the parallel lines, that if the angle down at the bottom here is 42, and this one's 90 because I just drew a perpendicular line, then this angle is 180 minus 90 minus 42. Okay, so that's 180 for the triangle. There's 180 degrees in the triangle, minus 42 for the known angle, minus 90 degrees for the right triangle, and we're left with 48 degrees. So the angle between here and here is 48 degrees, and I don't even have to measure it. Just to be thorough, let me dimension that angle. That's 48 degrees, and of course I drew that one perpendicular, so I know that's 90. Okay. Also, look for, when you're trying to find different dimensions, remember there's 180 degrees in a triangle. Okay, and one of the angles that you have to get is the angle between this line and this line. Well, if you extend this line to this line where they meet here, what you've done is you've made a triangle. Okay. So in this particular case, I know this angle's 51, and I already explained it. That one's 51. There's 180 degrees in a triangle, so why not 180 minus 51 minus 51 is 78 degrees. So I should be able to get Inventor to measure that angle. Okay, and sure enough, it's 78 degrees. Okay, and I found that not through graphical means like I'm demonstrating to you. I found that out mathematically. So there was just one trigonometry principle that I used and one geometric principle that I used, and that will help you answer most of these questions. Just to show you one more. Oh, actually, I already covered that. So I think that'll be enough information to get you through this exercise, and that concludes this video.